What is Beckmann rearrangement? This is a rearrangement reaction, that is that we do not add any component to the molecule itself. The molecule itself gets changed to a different molecule by induction, by when we induce it to some external agents. Okay, so we introduce it to some external agents, but that external agent do not get incorporated with the molecule, right? So here is our starting material. In Beckmann rearrangement, the starting material is this kind of compound where we have two side chains with the carbonyl group. Where this comes from? This comes from a carbonyl group compound, that is this kind of carbonyl compound, and if we react it with NH2OH in presence of some acid, then it forms this compound, right? And this compound in presence of some acid, this may be H plus or PCl3, PCl5 also works, because these are Lewis acid, whether they are bond-state acid. So we can conclude it that acid, in place of acid, whether it is Lewis acid or bond-state acid, in presence of acid, this converts to this amide, right? So this is an amide compound. So our final product in Beckmann rearrangement is an amide compound, right? Okay, very good. So this can be a synthetic procedure for amides, right? So this amide forming reaction. Okay. So now once we know what are the basic reaction of this Beckmann rearrangement, what are the basic thing, we can go for some examples, right? So the most popular example that I'll show is this one, that is we have this 6-membered ring, and then this thing, right? So we have the same groups, that R and R prime are same. It's a cyclic compound, and in presence of acid, what it forms? It forms this. It forms a 7-membered ring, and this is a 7-membered ring, and this will form an amide. So this is called caprolactam, and this is used in synthesis of nylon. Okay, that is not important, but this example is important. This is a synthesis of caprolactam. So caprolactam is being synthesized. It's synthesized by using Beckmann rearrangement. Okay. Now once you know the the basic reaction and one representative example, now let us move to the mechanism of this Beckmann rearrangement. So now we'll discuss the mechanism, right? So this is our this was our basic reaction scheme and one example, and now we'll move to the mechanism, and also I'll show mechanism for the synthesis of caprolactam, as well as I will show some other examples as well. So now let us come to the mechanism point. Mechanism of Beckmann rearrangement. So first, what do we have? We have this R, N, OH and R prime. These are some alkyl groups or other functional groups. Okay. Now in presence of acid, when you give acid, then what happens? These lone pairs of oxygens, they abstract the proton of the acid, or they get attached to the Lewis acid. How? If we have this PCl5, then it gets attached to the PCl5. So it forms what it forms? It forms this compound, NOH2 plus. If it abstracts the proton, right? If it abstracts the proton, it forms this OH2 plus. Understandable? Now this OH2 plus is a good leaving group. We all know that this is a good leaving group. Now what happens? In the medium we have this water, right? With this water. Now this can get attacked by the water. Okay? It can get attacked by water. Right? But that before that, what will happen is before it forms the adapt with the adapt from the water, there will be a small rearrangement. What will be that? That is important. That is, you can see this is a double bond, so this is a highly ordered structure. In double bond, there we have cis and trans. So this group is trans to this leaving group OH2. So what happens? This R group attacks this N nitrogen, and this OH2 group leaves. So this is minus H2. So the water leaves, and what it forms? It forms this kind of compound. Sorry, now this R is not this side, but it is to this side, right? And we have this R prime, and here we have a positive charge. Okay, now we have a positive charge on it. Very nice. So we have a lone pair or nitrogen which comes down to neutralize this positive charge, and it forms this. Sorry. And it forms this. Okay. Now in medium we have water. It is very simple now. We have water, and water has some low oxygen has lone pairs. It attacks at this position. This opens up. So what we get? We get this double bond O, hydrogen and hydrogen. Oxygen has a positive charge on it, and R prime. Now you can easily see what can happen here is that nitrogen has lone pair, and it abstracts this proton from here, right? So what it forms? It forms a structure like this. HR, it has positive charge, double bond O, H, and R prime. Now it can form easily. It can easily form a resonating structure like this. This comes down, and this goes. So this neutralizes the positive charge on the nitrogen, and forms ultimately the neutral compound, that is NH, and here we have R and double bond O and R prime. So this is our final amide compound. So this is the mechanism of Beckmann rearrangement. You understand? So first step is the attack of the to the acid from by the lone pairs of oxygen, right? Whether it is loose acid or bronzed acid, it will form an adapt. If it was, then it will be OPCl5 plus, right? If it attacks, this forms an adapt with the PCl5. Now the group that is trans to the living group that is water, or in the adapt that is forms, the trans group migrates. This is a migration step. This is called migration, right? This group migrates from carbon to nitrogen, C to N. This group migrates from carbon to nitrogen, and oxygen is leaving. Now this structure, this resonating structure, this gets attacked by water, and finally there is a rearrangement procedure by which it forms a neutral amide compound, right? So this was our mechanism. You can pause this video and write down the mechanism of this reaction. Now I'll take a simple reaction with caprolactam as our example, and we'll try to write down the mechanism for the same. The mechanism will be same, only the R and R prime will be different, right? We'll write down the mechanism for caprolactam right now. So we have caprolactam. OH, very nice. This caprolactam, we add H plus. So what will it form? It will form this adapt, right? NOH2 plus. Now what will it form? It will form, okay, try to write down it this mode only. Okay, so that will ease your problem to understand this thought, right? Here you have this positive charge now. Okay, fine. now this gets attacked by water, and what it forms, I'm not writing the resonating structures now because we all know that we have nitrogen here, so nitrogen has lone pairs, these lone pairs can come. Okay, I'm showing it. And it can form a resonating structure like this. A resonating structure like this, right? So this is a resonating structure, and you get there is water in the medium, and it attacks this carbon. So what it forms? It forms this. It forms this. Right? This forms this. Now, after the removal of the proton by nitrogen, it forms this another structure, equivalent structure, you can say. I'm writing this structure in very bad condition, right? Another equivalent structure is this, the positive charge, and here is OH, and it now finally forms what? This caprolactam. Okay. This caprolactam. So this is our caprolactam. This is our final product. So understand the mechanism. So if someone asks you to write down the mechanism for Beckmann rearrangement, now you can write down it, right? Let us move to the next example that will have different groups. Caprolactam has the same group on both sides of the carbon. So now we'll take an example of with different group to the carbon, right? What is the example? Let us take one simple example of what you say. Let us take an example of simply. Okay, let's say a simple example. Let me take. Okay, to describe you. Sorry. So this is our starting material. Let us take a methyl group and a phenyl group here. Okay, this is our starting material. Now we add H plus. The first thing will happen is this will form an OH2 plus adapt, and this will have same, right? It will be same. Now this leaves, so it forms this. Now here is one important thing, right? So now this step, that is a migration step, is important, very important. Now there is a probability of migration of CH3 as well as phenyl, but which will migrate? I have already told that group that is trans to the leaving group will migrate to the nitrogen, right? Though the migration ability of phenyl is higher than CH3, the what is migration ability? That is a matter of discussion, a long discussion. But migrating ability of phenyl is greater than methyl, but here methyl is trans to the leaving group OH2, so methyl will migrate, not the phenyl. So what it will form? It will form this. It will form this CH3 or this phenyl group here, positive charge here, right? This will form this. This could also have formed this, but this will not be formed. Why? This will not be formed. Okay, so only this will form, this will not form, this migrates and this leaves, because this is not trans to the living group also, so this will be the product, this will be the adapt. Now this gets attacked by water, and I am writing this using a shortcut. Where the positive charge is created, you put a carbonyl group there. So you write down the basic structure of the, and you put a carbonyl group there. Then you balance the remaining part. So this will be our final product. Okay, so this will be our final product. So you understand now what is Beckmann rearrangement. You can now write down the mechanism of Beckmann rearrangement. If anything is given to you, you can write down it. The mechanism. What is the mechanism of this Beckmann rearrangement? Okay, let us suppose let me take this one. Whatever it is, some yeah, we have phenyl group, and let's take here we have this OMe group, and you put some H plus. So what will be the product? Okay, so remember how you can do this. You can do this by simply removing the OH and putting the trans group to the nitrogen. So you put the trans group, that is the phenyl group here. Okay, then we connect it and we write down the other group as it is, because this doesn't move, and put a carbonyl group here. So this will be our final product, and nitrogen will have a hydrogen to balance its valency, right? So this will be our final product. Anything you write down, and we write down the product, right? So let us take this one. This is a simple example. Someone has given this to you, OH X, then they have put some H plus on it, then they have given like Y. Identify X and Y. So you can easily say, I've already told that this forms, when it reacts with NH2OH, it forms this adduct. Sorry, it forms this nitrogen and OH adduct here. And when you give some H plus, so this is our X. When you put some H plus, then what you do? You remove the OH and you put the trans group to nitrogen. So you put the trans group to nitrogen. So you put the trans group to nitrogen, and you put the remaining part, you put a carbonyl group here, and you balance the valency of nitrogen, right? So this will be our final product. This will be our Y, and this is our X. So by that way, you can easily do any Beckmann rearrangement problem, okay, just by removing the hydroxyl group and putting the trans group to the nitrogen, and then putting a carbonyl group at the adjacent carbon to the nitrogen, and balancing the valency of nitrogen, right? So this was all about Beckmann rearrangement, right? So hope you have understood what Beckmann rearrangement is, and what is the mechanism of Beckmann rearrangement, and how you can do simple reactions on related to the Beckmann rearrangement. Now if you have any doubts regarding this Beckmann rearrangement, or any other problems of Beckmann rearrangement that you are not able to solve, then put it down in the comment section and I will be solving them.